So as you know, we don't do amateur radio equipment here, but we do certain models of licensed business radios, and one of those is the Maxon PM150. So no, it's not a CB job, and we've done one of these recently, but here's kind of another two. Now my friend Stewarts M0SDM passed across a PM150 which we programmed, but it won't go, it's the wrong band. And Mr Chippie has volunteered to change all the 30 odd capacitors to make it work. It won't even lock. I was going to show that, and it was going to be kind of part one of that, but finish this. This is coming from somebody who we did a CB for, who is suitably licensed for this, and he wants it on 4-meter amateur, and on the face of it, it looks to be the right band. It also looks new old stock, which is incredible. January 1997. Belongs to Tom. So what we're going to do is we'll start the video off here in Mr Chippie's domain. And what I was going to show you is that we've programmed Stewarts, but it wasn't going to lock or do anything because of it being out of band. So instead we'll show you this one, which is not also going to lock, but it will hopefully adjust so it will eventually. So hoping it's the normal model and not the systems model, that we can program the systems model as well. SMX4050 NLA should be the right kind of version. So when I did the training course on these, I said, what's the correct tool to open the lid? And they said the biggest screwdriver that Woolworths sell. So we haven't got Woolworths anymore, so we'll have to cope with that. But it's a standard version. If it's a systems version which uses a different programming protocol, then there's another board on top. So the standard version is 16 channel. The systems version, which does selective calling and all that kind of malarkey, it's either 32 channel or 99 channel. I've never seen a 32 channel one, I've only seen a 99 channel one. And that uses programming lead SMP4002. Now this uses programming box SMP4001, and again I've shown you this before. This is the programming box. There is another programmer called SMP4000, which is a hexadecimal thing with a little fluorescent display, a box about like that. It's standalone, it doesn't need a computer, and it's a right faff. We do have one. A, I don't know quite where it is, and B, I don't think I remember the you need to put a security code in for it to power up. You know, just so that they can't reprogram things. Right, so the first thing we do on the software, we're using a Toshiba T1910, which was a lot of money at the time, was well over £1,000. But the point is that anything other than a 4.3 meg PC can cause snags in programming. And if there's a background noise of the washing machine going round, that's in the next room. In the UK, washing machines tend to be in kitchens, the kitchen's the next room. So, in fact, the dishwasher's going as well. Doing that, we've got solar panels here, so take advantage of when there's a bit of light. So, set up the programming parameters. It's SMX. You forget about the dash there. 4050 NLA. Enter. So we're going to take the EEPROM out, which is the 8-pin one there, and out of interest we'll see what the radio is on. I could use a posh tool for this, couldn't I? I could also force it out between my wooden handled screwdriver and what's supposed to be my super powerful fingers. Well, this is a tough one, I must say. We'll use the surgical scissors. What we don't want to do, of course, is to bend any pins. I'm kind of waiting for two things on the organ build, and that is paint to dry. Can watch that all day, and Mr Chippie to help when he arrives here later to help lift a £120 in weight piece of the casework right onto the top. I put the scaffold tower up for that. So we're going to use EEPROM position 1, and I had the sense to label this, and the pin 1 is where this is one of these zero insertion type of connectors. So the pin 1 is of course the dot, and pin 1 is to the lever, so we can put that in like so and clip it into position, so it's in position 1. So on the computer, select EEPROM to program. Well, it's 1, it's defaulted to 2. Enter. Read write, read. So that's what the radio has in it, and to be honest, this looks to me like it's the factory default. When it's ship radios, they do not talk to each other. That's very, very important. Never ship radios which are capable of talking to each other, because they can be stolen or used without a license easily. So that looks to me like that's what they've done. So we will pull up the file. So we'll come out of that. Read file. We're going to use 4M AKD, so the channels are exactly the same as the AKD set. So that's brought the file up, and you can see that channel 16, which we've set as priority channel, is 70.45. I've got a timeout timer there for 4 minutes. We could turn that off, whatever, but that's how I tend to have it. Some of these other features are for enhanced things on repeaters and things, which would be, I'm talking about business radio repeaters, not ham radio repeaters. So now we'll program this. Radio serial number 97. You don't have to put the serial number in, but it's useful if the serial number in the EEPROM fits the serial number in the radio. Exit. Now I'm going to read that back. So we'll just make sure it's actually done it. That's interesting, it's done absolutely nothing. Looking for... Right. So when I programmed it, I didn't tell it that we were in... Do you know what? I'm going to move the... If it wants to have the EEPROM in position 2 all the time, I'll put the EEPROM in position 2 and have less faff. Right, we'll bring the file back. 97 I'll try again. And that's why you read these things back. Just imagine driving up to take some radios back which you've programmed and you haven't tested them. Of course these do have to be tuned. So read the EEPROM and hey presto, it's actually in this time. So I'll take the EEPROM out, put it back in the radio. He's asked us to be this on 30 watts. I don't even know if we've got a power supply that will let us do 30 watts. That's interesting. I'm not going to shut this down in case of some anomaly, so I'll go over to the normal workshop, Test Bench 2, where we do CB radios. We just don't have anything set up to do with all this building work going on here. We've only got the one test bench set up, and we've told all the business customers that we're not doing anything until the organ's finished. So I've just kind of slotted that in to try and help somebody, but it could be back to bite us because I haven't got a power supply that goes above 3.5 amps. Okay, so here we are on the test bench. I've coupled it up to the normal 3 amp power supply that we use, and I've turned the power down to 5 watts so that it's within the current capability of the power supply. So that was a way around that. It is locking as far as the VCO goes on transmit and receive, but just for the video there is a test point here and there are trimmers to adjust that VCO. So what I'm going to do, I'll just turn it off a second. We'll take these screws out just so that it's more obvious to you. You don't have to do this in reality, but just so for the video, just so you see what you're putting your test prod onto. So the one I was going to show you, which was Stewarts, which I don't know where Mr Chippie's put it at this point, it will not lock because it's going to need capacitors changing values to turn it from one part of the band to the other. Here we go. So the test point, if I put my other glasses on, turn the radio back on. And by the way, you can hear receive, and that is, for that scratchiness, that is 100 millivolts. So that's a massive, massive signal because it's so out of tune. So if you try to receive without adjusting the receiver, well, it probably would work for 50 yards. So if we see what lines up there, everything does. Right, I'll get the test meter. I'm not going to get the service manual out for this. Because I've done these recently. I think that's the test point. It is the test point. So on receive, and I don't know which one's which, we'll find out by trial and error. So between the trimmer and the coil there, I've got 3 volts. So let's see what happens on transmit. 2.3. Try and get that on there. So we're actually turning these down. So we've got just over the 3 there on transmit, and we've got, well, about 3 on receive. So I'm going to move it to channel 1 because I'm on channel 16, just at the other end of the band. And on receive we've got 2.94, and on transmit we've got 2.96. So it's in lock throughout the 16 channels. There we are, back to 16. So that's done that. And you get an error code, which I was going to show you on Stewarts, if it's out of lock. You get error codes for lots of things. I think very high SWR is another error code. So the next thing I'm going to do, we'll just make sure it's on frequency. You've got to coarse and define for the frequency trim. So that's the reference crystal. And you'll see quite clearly on the board it says NLA, so we do know what version it is, just in case the bottom lids get swapped or the serial number gets taken off because somebody stole it. You know, nobody ever checks those serial numbers, and so taking serial numbers off, you start to think, oh, wonder what's happened to that then. So put picture in picture on. See, it should be transmitting, especially if I switch it back on. So it's doing a full 3 watts, and we could make it, we're drawing 1.8 amps at the moment, so we can go up a bit higher. So I will go up for the moment. I'm not bothered about that. What I am bothered about is whether it's on frequency or not. So we'll just put the camera, or a camera, onto the frequency counter, and it should be 70.450. So it just needs to pop up a bit. So there we are, 70.45. It's quite close enough. There we go. And let's just see where the deviation is. I'll have to set the deviation meter because we're normally on UK channel 20. So we need to put it into a different band altogether, of course. So let's see. I think we're there. Voila. So it's a bit quiet. I'm going to have to check which one is deviation, folks, because one does digital code squelch, one does CTCSS, and one does deviation. So I will just have to check with the manual for that. But it's a big binder, I don't really want to fetch it out. And oh, and expect to pay 100 quid for one of those on eBay. You know, it's not something. Someone says, can you scan your manual and upload it? No. Right, so I've looked up the appropriate preset. It's this one. Wallow.
One of them's, I think that's DCS, I think that's CTCS. So I really can't remember. I don't know where the full manual is. It's not where it's supposed to live. Perhaps I've been burgled and all the nicked was the PM150 manual. Minded to take one look and wipe the feet on the way out. Right, so we've got VCO done, we've got deviation done, transmit power, as I've said before on these, is just down there. It's on a little bit of an angle under the die-cast cover. So we'll go through receive, plug the cyanide meter in, put that on the screen. Helps if we put it on channel 16. Just going to check quickly we're still on frequency. Yep. So just like I would with a CB radio, I'm just going to check the detector. Now it's a new set, this. I'm not expecting any snags at all. I can't do that because we can't put a bigger signal on. Oh, I can. That's enough signal. Trouble is, I just don't see enough of these to remember what's what. Yeah, it's that one there. Right, back to cyanide. We're on cyanide on there. About 4 dB as usual. I think we're going to be turning these down. So this is 100 microvolts now. That's 30 microvolts, 10. Three. One. Right, now we'll start with the attenuator. So So we're now at 0.6 of a microvolt. I'm now at 0.15 of a microvolt. I reckon this is the best one I've ever seen. Still dropping the attenuator off. Just going to check the detector once again. This time I'll show you that. There we go. So back to the cyanide meter. What's it now doing? Well, folks, it's doing. I'm in the wrong. I'm in the previous scale. I thought it was a bit good. I'd put it up at 10 dB. At the moment, it's doing 0.9 of a microvolt. Just see whether we get a fraction more. Well, that's where we are. So for 10 dB, it is 0.85 of a microvolt. Okay, so that's done. That's now should be working okay. Let's just go back to transmit. Now I'm going to set this to as high as I can get for the 3 amps my power supply will do. So at the moment it's 3 watts. So we're at 1.7 amps. Yeah, it's about 6 watts is the maximum I can do with the power supply I have here. Now, Mr Chippie, we haven't had the power lead with this, so I'm having to run it on the crocodile clip leads. when Mr Chippie arrives, I'll ask him if he'll make me up a power supply, make me up a power lead. We have the mouldings in stock. It's something we can do. Don't think there is anything else to adjust. Just check this isn't transmit. No, I think we're spot on there. So I'll put the top lid on it. Except the top lid's in the other workshop, so I won't put the top lid on it. So I'll look back at his paperwork, and he said something like 25 or 30 watts, which it will do. I think they are rated at 45 watts for the American market. So it's nice to see a radio that's new old stock and isn't a return and new old stock broken. Just check the squelch works. It does. There we go. So there's one or two things you can do from the front. If I can't remember the sequence, I'll muddle through it. I think you hold 1 while turning it on. Do you? Or do you hold scan while turning it on? Or do you hold 2 when turning it on? Oh, that's the dimmer. Yes, now we're in program mode. So the priority channel is 16, and you would be able to alter that, but we're keeping it as that. Turn it off, put it back on, it'll boot up at 16. But there you are, that's it. So you saw how deaf that was. It was oh, what did I say it was? 10 millivolts to hear anything on it. And so we don't need to show you any further. We'll simply turn the power up when it goes on a suitable power supply, and then pop it back to the customer. There you are, trying to remember and not using the service manual. This is going to be a follow-up with the one that I wanted to show you, which belongs to Stewart, in going through all these capacitors, and there's a lot of them, taking both the boards out, and I say it stands at the moment that it won't even lock, so it's got error 3 or whatever it is. So this can go back. Thanks. So just add this bit on after I've done the radio, so we're just going back a bit. I've brought this radio into my radio van, and I've put it on the battery which is in there for radio, and as in not the vehicle's battery but the radio battery. So if we key this up, let's see whether we can get I mean, this isn't a high precision power meter, it's the kind of thing that's 89 quid. So right, so on this meter, just done the calibrate, it says, well, I'm on the 20 watt scale, well, it actually says I'm doing about 3 watts, which is ridiculous. It just shows how inaccurate this kind of thing is. Right. So that's showing 20, so we'll just change it to the 200 scale, just check we're still in calibration.
It's hard to tell on a meter as crummy as this. So that's 20, so if we give it a bit more than that, that's going to be 25-ish, and this is at 12.8 volts, so if he's running this at 13.8 volts, I dare say it's going to be around about 30 watts. But I say it's not something we can normally, we just cannot do it at the moment because of the building work and so on. So it's programmed up, power somewhere about where he wants it, and I brought my Maxon walkie-talkie here. Testing 1 2 3 4 5. Testing 1 2 3 4 5 5 4 3 2 1. So yes, it is. That's the on the air test. And the other thing I wanted to show you. So turn that off. Unplug it from our power lead. So I found Stewart's one, which we programmed, and I said won't go on because it's the wrong band. So he's got a bit of a tatty mic lead. He's going to have to get another mic. Ah, no, I'm telling you all wrong. This is VHF high band, and we're going to be turning it into VHF mid band, so it goes down to 2 meters. So I'm telling you a load of rubbish. So Stewart's is not 4 meters. Stewart's wants to go on to 2 meters, and that will be an interesting thing as Mr Chippie changes a load of capacitors to try and make that happen. So that's what that one's all about. I've forgotten the story. So that's where it ends, and I'll say once again thank you for watching. Tried my best there to use the battery in the van to turn the power up from the 5 or 6 watts I had it on the test bench.